And Dave, I can turn it over to you.
Yeah. Yeah, so the
Thanks.
context for this was Brian came to me with a few questions around dynamic and static analysis, or static and dynamic testing. And they were really good questions. And the general thought that I came away with was, it's not just dynamic analysis, it's not just static analysis, it's really their complementary approaches to solving the same problem, which is trying to uncover security vulnerabilities. And there are probably some historical reasons for why static analysis has kind of been around perhaps longer than dynamic analysis, partly because it's a type of analysis that doesn't require running the actual applications. And so therefore, in some ways, it was kind of easier to rationalize and to kind of approach the problem. But yeah, I just wanted to walk through some of the questions that Brian shared. And so I'll just kind of dive into that now, but feel free to stop me along the way, because this is supposed to be casual and kind of informal chat with you guys. I did prepare a couple of slides to kind of walk us through some of these questions, so I'll share that now. Just give me a moment. So the first question that Brian asked was, so many customers understand or familiar with static analysis, and if they're not familiar with dynamic, what are the top 3 bullets that you would use to help position dynamic analysis? And so I thought about this really cool presentation from the Worldwide Developer Conference put on by Apple. And they had this really cool approach of thinking about just general testing. How do you approach testing applications, given that there are a lot of hard problems to solve, not just from security perspective, but just from a general QA and functional testing perspective. And their thought process, or the way they laid it out, and I don't know if this is somebody else's approach that they were presenting on, but they had this pyramid of tests, right? And so at the bottom of the pyramid were unit tests. That's your basic function check to see if something looks like it's, like if it's a math function, if you do 2 + 2, you should get 4, right? That's kind of the unit test. Integration test is when you take 2 + 2 is 4, and then you add that with some other function. You should get 2 + 2 is 4 plus another X value. For any value of X, you should get, whatever that's supposed to be. So when you start to integrate those functions with other things, you start to add complexity. And the more complexity you add, you ultimately end up with a fairly complex system where you really need something that's end-to-end. So you're talking about lots and lots of computers talking to each other and different processes happening all at the same time. And that's where things start to get complicated. And so that's the top of the pyramid here. So what I really thought was interesting is this way of thinking, right? So traditional QA and engineering and site reliability engineers will be super familiar with this type of thought process. So unit tests at the bottom, integration tests in the middle, and system tests at the top of the pyramid. And if you look this up on Google, you'll find tiered testing as a way of handling functional testing. And so the real approach that I'm taking to answer this question is really from a developer perspective, which hopefully will resonate with our audience, our target audience. So if you consider that real-world testing requires some amount of integration end-to-end testing, if we take that assumption to be true, because that's basically, if you look at the QA functional testing world, they've already taken that to be true. The reason they need those things is because they need external systems to be fully tested, meaning, so if I have a service that's designed to handle logins, to accept a username and password, I need to be able to test that system separate from the product that actually uses it. And so that's kind of an external system that has to be tested alongside another process. And sometimes you need these things to interact with non-deterministic user input. So that's the person interacting with the product. And of course, some of those special types of scenarios require specific workflows to actually trigger behaviors that are actually interesting from a functional testing perspective. And I think we've all had one or two experiences where we test a new product and we hit a bug. And usually that's because some unit test, some integration test, or some functional test that failed to actually recreate the scenario that you actually recreated when you were interacting with the application. So that moment that you realized that there was a bug was that moment that unit testing, and if we look back at this pyramid, integration tests and system tests all failed to find that flaw. So if we consider that, the hierarchy of security testing can actually be sort of drawn in parallel to the hierarchy of security testing in a way. So hopefully this starts to make some sense now. If you look at static tests are very much like unit tests. They're kind of like the very basic quantity that everybody wants to have in place because one, it's the fastest thing to run, and it's the quickest test that you can basically get some feedback for. But ultimately, you have to start looking at how the app behaves in on real devices, in real environments with real user input, and ultimately under different conditions that are really hard to test using just a purely static approach, so not actually running the application. So feel free to stop me at any point here if I'm talking nonsense, but hopefully this resonates with people that if you've been looking at this from the unit test integration and system test perspective, we can also talk about this from the static and dynamic perspective and behavioral as well. So ultimately, why dynamic? Well, for developers familiar with QA, for these folks, well, the bottom of the testing hierarchy is static. We kind of mentioned this, and dynamic analysis is capable of finding some types of security risks that static analysis may never find. So for example, flaws in code loaded at runtime, or third-party libraries that may never seen and they only exist during the, while the app is actually running on a real device. So when moving on from this topic, Brian asked, so how are people getting by with static code analysis only? Well, how are people, app developers getting by with unit testing alone? Well, the truth is that they really aren't. The reason they aren't doing dynamic today is probably because it hasn't been an easy option for them, and they instead rely on pen testing to fill this gap. That's the theory. So they think they're getting by because they haven't had dynamic testing to show them everything that they're missing. So when we speak about DevOps, we get the feedback that static code analysis solutions, aren't they shifting further to the left? Well, if you're talking about static testing, you also have to qualify it by whether it's on the source code of the application or if it's on the compiled binary of the application. So let's first talk about, well, the life of a bug. So why should we fix bugs, and why is DevOps important in the first place? Well, we should fix bugs because they can get really big really fast, and it ultimately, the longer you wait, the harder it is to kill them, and the more people it might take to actually fix them. So if you think about legacy code and all that, you could actually be having to break legacy code because you're fixing a bug. So you generally want to fix those bugs earlier. And then from a security perspective, obviously there's that brand, the threat to the brand that motivates a lot of people to actually take some action. But really from the pure bug killing perspective, it's, you're better off fixing them earlier. So I think we can agree upon that, and that's the whole DevOps movement. And for security as well, totally agree that the further left you go, the better. Great. However, if you take a look at the process of building a program, if you break it into its like high-level corresponding parts, this is kind of an old way to look at it. But you have some source code, you compile it, it turns it into some assembly binary object file, and then ultimately it gets loaded into memory. And but if you notice here, there's this thing called libraries. Those libraries actually may not exist in the form of source code. So that means that depending on what type of testing you're doing, if you're doing source code based testing, you're only going to see things at the stage of the pre-assembly stage, right? So you're actually not going to see potentially some of the third-party libraries that are included in the build process of an application. That could be third-party libraries, that could be first-party libraries. But if you just expand this system, this sort of picture out further, we're just looking at one process. That's one program. If you expand that out to all the systems that are sort of part of the overall system, complex workflow of any enterprise software, well, this is expanded further out. There's lots of programs, lots of different programs with their own libraries and different processes that get loaded. So just at a fundamental level, just thinking about this, if you're only doing things pre-compilation and only looking at the source code using static source code testing, you're going to miss out on all the important things that happen actually just after that, which is a big part of why we do binary-based testing, because we're actually looking at it from the process perspective before it gets loaded into a real device or into memory. And then we have dynamic analysis to help us understand what the app does, in the context of all these other systems, which is super important to sort of see where the data flows. We talk about data at rest and data in transit. Data at rest is, how does the data live on the device? Is it encrypted? All these different aspects of how the data is stored. But even though that's the data isn't in motion, it's data at rest. it's still something that's really difficult to determine using just pure static analysis, because ultimately we're talking about processes interacting with the file system of the computer. So just kind of jumping up a level, we're kind of getting the nitty gritty here, but basically dynamic testing is what enables you to see how an application and a program sort of deals with the real world fundamentally. So in my opinion, it's a valid point that finding and fixing flaws further left is better. But again, recall that not all bugs exist or are evident at the source code stage. And if you think about it, white box testing has been around for a really long time. That's essentially people doing code review and tools being used to find vulnerabilities using static source code techniques. But obviously that hasn't been a silver bullet. That hasn't prevented all of these issues from still happening out in the wild. So obviously that approach alone isn't going to work. So just trying to move through quickly here. When we speak to customers that understand dynamic, they compare us to other dynamic solutions. Why do you think, what do you think is the key differentiator in our approach, and why don't emulators work? So a key differentiator for us, from our perspective, I guess, would be one thing is that iOS dynamic analysis is hard. It's hard to build a system that does iOS dynamic. We've spent, a lot of time trying to figure out how that works. And it's something that we've not seen a lot of our competitors being able to do. And, I think a lot of folks we've seen are actually using manual pen testing to sort of overcome that. But there are definitely some people that have created tools that they're using for manual pen testing to sort of overcome the challenges of doing dynamic testing with iOS. So that's an obvious differentiator for us. And then if you look at the depth of the data, and that might not become evident to the average customer until they go in certain depth and look at the data in detail, but I think that's a key differentiator that, that we should be talking about at least. Emulators, so emulators don't exist for iOS actually. There is one company called named Corellium. Corellium has been in stealth stage, not stealth, but they haven't quite announced a fully functional product yet. They are saying that they have an emulator, and I've seen some aspects of the product, and it does look really cool. But in reality, there's nothing on the market right now for doing emulated testing for iOS. But even if there did exist something like that, apps behave differently in emulators versus real devices. And if you're looking at the behavior of an application, you really want to test it in the environment it was designed to run in. And while there are certain trade-offs and benefits to using an emulator, something like being able to tear down the process when you're done with it and sort of build it right back up from scratch when you're done, when you're ready to spawn a new one. That process is hard for you to do with a physical device. That's something we've had to deal with. There's a lot being traded off in taking that sort of shortcut. And it is a shortcut because ultimately you're just getting an approximation of how the device and app really run, how the app runs in reality. And the truth is that there's some apps that actually work completely differently in a simulator or emulator versus in a real device. And malware is a really good example of that, because essentially they know the analysts will take the shortcut of running the malware on an emulator. And so malware actually can behave differently. It's just one example, but there are apps that actually behave differently in one environment versus the other. And we can go into more detail on that later if that's really important to some of your conversations, but right now, hopefully that's helpful. So that said, emulators are helpful, and we do provide it in Workstation for advanced analysts to use. One of the questions we get is the pushback about configuration and managing scripting. We're essentially taking that component of the normal manual pen test and making that a reusable artifact of the DevOps lifecycle or DevOps process. And that's very valuable because essentially you're not throwing that away every time. So I'd like to put together a picture here where we show like the 2-week timeline of doing a pen test. And I don't want to say that our automated testing is 100%, going to cover all the things that a manual pen test does. But I want to draw the parallels between the fact that there is some configuration, there is all this stuff that's happening behind the scenes when you're doing a pen test. It's a little bit more upfront and an initial investment when you're doing automated testing to configure, provide things like username, password, UI automation. But the truth is that those things always existed, and that we're just making them an actual reusable artifact of the dynamic process and of the DevOps process, so that you actually get the benefit that accrues between different pen tests, if you will. If you look at it as an automated pen test in a way, you're getting the benefit of taking that configuration and paying for it once, or paying for it incrementally or a little bit over time, rather than it being completely thrown away. So some of that configuration is totally reusable, and one of the ways that you're able to get benefit of full automation in the CI/CD process. So the truth is that scripting, someone in the organization is already investing time running the application. That's either your pen testing people that you're outsourcing to, or somebody on your own team that's manually interacting with the application because they don't have the benefit of our tools. So since this is already being done, why let it go to waste? People in the QA team and in the functional testing team at these companies are already doing this type of scripting and automation, UI automation for purpose of reliability testing, as I mentioned earlier. So the ideal situation is to reuse that capability for the purposes of doing dynamic testing. So my last slide here was something I just put together at the last minute, I'll be honest. The point was to try to describe why it's not static versus dynamic analysis. It's really kind of static and dynamic analysis, and it's because the ideal situation, and you lay this out on a graph, and this is totally like my artwork here. If you look at it, dynamic analysis has, as you increase the depth, so it's the line on the left, as you increase the depth, you decrease the false negatives. So that means you're less likely to miss something important as you increase coverage. But the converse side of that is that you have very few false positives, right? There are very few false positives because you're doing dynamic analysis. You're seeing how the app runs in practice, and that's a big difference from static analysis. On the right side of this chart is the static analysis, where as you increase depth, you actually get more false positives. And so what I was trying to get across here is that there's a happy space in between here, and I call it the steps to success. I don't know, maybe I'm sure this won't catch on, but the steps to success, in my opinion, is somewhere in the middle, where you're using the benefits of both dynamic and dynamic analysis for what they're good for. And that's why we've, as a company, focused on doing both. I would say we've been more focused on dynamic analysis because it's a really hard problem, but there are definitely benefits and things that can be learned from both sides of the different types of analysis. And you can actually try to leverage information, things that you learn from static analysis, in the dynamic analysis process. So let's not say that one versus the other is better versus, I think that it's more about, where we've personally focused our time and where we think the most value is, but ultimately we do have static analysis in our products for a reason, and we want to continue to improve them to make sure that we get the sort of the happy space in between here, which is lots and lots of really good coverage and hopefully low false negatives and decreased false positive while increasing our depth. So hopefully that gives you guys a little additional ammunition to work with. And if you have any questions, I'm happy to try to take a couple before I have to head out here.